with the topic. In the very last class, we have just finished our chapter number 2, that is the solution. We have completed the solution topic very well, and I hope you have grasped what I have tried to deliver you, and you have made the notes through and solved the exercise through. So now we will start with our fresh topic, with our fresh chapter, that is chapter number 1, the solid state. See class, you know very well, as I have shared with you all in the very first class, that our all matter are made up of 3 different states: solid, liquid, and gas. The solid state, this is your first chapter. The liquid state, that was solution, which we have just completed. Now we will start with the topic, the solid state, which is the most important topic, and of physical chemistry. And you know very well, the physical chemistry is made up of your 5 chapters. Each chapter has each importance and cover almost 4 to 5 marks. It may vary up to 6 to 7 marks too. It depends. Okay, so let's start with our topic, that is the state. What actually the solid state is. You know very well about the solid, very lower classes. So I will just have a brief recapitulation what the solid defines you. The solid has definite properties. They have definite shape, they have definite size, they have fixed melting point, and their intermolecular forces are so strong that they even can't be compressed. They are so rigid. These all things you know very well. Okay, now the solid are divided on 2 bases: amorphous solid and crystalline solid, which is your first topic. That are solid are basically divided into 2: crystalline and amorphous. So what is crystalline solid and what is amorphous solid? Crystalline solid, as the name suggests, its structure, its arrangement is like a crystal. It's also known as the true solid. Why is it? It's known as true solid. Are arranged in a well-mannered, perfectly order. Okay, so they also known as true solids. They have definite shape, they have definite melting point, and also known as long range order. Now, what is long range order? Long range order means we can say that in this solid, in this crystalline solid, we can show our constituent particles and their arrangement for a long range. Like they are arranged, and they are arranged in a well manner, they are arranged in a order, and this order is for long range. This does not end for some time, and after some time its direction change, its arrangement change. So I can say that there is always an arrangement like this. This kind of arrangement, and this is for long range. Like if I'm having this particular whiteboard, this is behaving as pure crystalline solid. Okay, because all these particles are arranged in a fixed order, and this is not for a short order. Like if I'm talking about this portion, they are arranged in well manner, they are arranged in order. After some time the order is disturbed. This is not so. Okay, that's why they are known as crystalline solid. All the crystalline solid that you know in your daily life are, for example, we are having metallic solid like copper, zinc, or silver, gold. These all are crystalline solid. Now the question arises, what's the difference between amorphous solid? The amorphous solid differ from the crystalline solid in the arrangement of particles. Their arrangement is not fixed. Arrangement is not fixed. Or we can say arrangement is not in well order. Okay, and they are also known as pseudo solid. These were known as true solid. These are known as pseudo solid. Why pseudo solid? Because since their arrangement is not fixed, so they are almost a false solid. Like they are behaving as a solid, but after some time their properties start changing. For example, glass. For example, quartz. Glass, quartz. See, class, I'll explain this topic a little bit more to you. You have seen that in some buildings which have old kind of windows, their windows having old glasses, after some time you can see in the bottom they get thickened. The windows, the glasses, after some time when they have become very old, just have an observation, they have become thickened from the lower side and the almost thinner from the upper side. So what's actually happened? We can say that the molecules are almost little bit flowing, but solids say that they are rigid, they can't even flow, they can't even compress. So that's why they are known as amorphous solid, they are known as pseudo solid. Okay, this question comes to you in board exam too, and this is very common question, that why do the old glass windows become, we can say, sorry, become thicker at the bottom rather than the upper? And the reason behind this, their property, their nature, and they are also known as amorphous solid. If I want to further illustrate these two topics, I would like to say, if I would cut these crystalline solids with a knife, you will have a sharp, you will have a plain, smooth surface. But if I'll cut the amorphous with a knife or something, what would happen? The surface would be irregular. The surface would be rough. That would be not smooth. Okay, so that's why these are amorphous solids. Another point, I would say the melting point. Since the arrangement is fixed, it would start to melt. It would melt at a particular point because they have fixed. But amorphous solids melt over a fixed temperature. They melt over a range of temperature. When you will come in chemical classes, sorry, in chemical chemistry laboratories or in higher classes, you'll come to know that some examples are that they do not melt a particular temperature. They melt from 118 to 123 degrees Celsius. Okay, for example, naphthalene, camphor that you would study in higher classes in your, okay. So that means they do not melt over a particular temperature rather than the crystalline. That's the first one. Okay. Now the another point is we have come to know about crystalline. We have to know about amorphous. The only difference is their arrangement. Another point is they are anisotropic in nature. Anisotropic. Okay, I would write here anisotropic in nature. What does it mean by anisotropic? Anisotropic means, is it clear? Is it? Yes. Anisotropic means if we want to see different properties, like I want to check out the refractive index, or I want to check out any kind of property like yes, reflection for some points. So if we see from different direction, they would show different physical properties. Crystalline, but since amorphous don't have any kind of order, we can see from any direction they would have the same property. See, a bit absurd to you that these are all very in good manner, they are true solid, they are long range order, or their arrangement is fixed, but still their property is anisotropic. Because let me try this one. If we cut this, we have just this particular molecule and we have the different arrangement over here. So if I check over from this direction, their physical property would be somewhat else. If I would check from this direction, their property would be somewhat else. So anisotropic is basically directional in nature. And that's the property which differentiate both are crystalline and amorphous. Okay, This was all about it. If I have another point, I'll check it out. Yes, I have covered all the points. And next we move to another topic. See, I had told this is long range order, so I would say this is short range order. I hope I have made the sense what is long range order and what is short range order. I have made clear that long range order means the arrangement is for the long period, or we can say for the whole solid. But for here, the arrangement is like for short range, then it's changing. So the arrangement is not for long range, the arrangement is for short point, and after that it keeps changing. That's why they are called long range order, they are called short range order, they are called pseudo solid, they are called true solid. Okay, I have cleared all the points, and I hope you have grasped the things. This was all about the differences between crystalline and amorphous. Next, we are going to move our another topic, that is, what are the classification of crystalline solids? See, we have come to know about amorphous solid, that there are some drawbacks into it, or after some time it starts flowing, it starts showing the different nature, different state rather than solid. So we have just skipped that, we have used that and just skipped that, like glass, quartz, plastic, and so on. Now and we want to know what are the different types of crystalline solids. Why crystalline solids are of different types. Very important topic and very basic topic. I hope you all guys know about this. Let's start. Crystalline solid means the arrangement of constituent atoms or ions. Now, which kind of atoms or ions are arranged into it on that particular basis, we can say that our crystalline solid are classified in different bases. Okay, so let's start. The first point is molecular solids. Basically, crystalline solids are of 4 types. Molecular solids, and then we have metallic solids, covalent solids, and left with the last one. I'll write it out after when I came to remember. Now start with molecular solid. What actually molecular solid wants to define? Molecular solids are made up of molecules, and also it is of 2 types: non-polar, polar, and hydrogen bonding. Now, what is non-polar, polar, and hydrogen bonding wants to define? I just want to change. See, the non-polar means the molecules, the constituent atoms are non-polar in nature. For example, we are having H2, we are having argon, Ar2, that is HH, Ar. You can say that it seems to be like, gaseous in nature, argon, but when we solidify them, when we freeze them, they get dissolved. What is carbon tetrachloride? The carbon with 4 chlorine. The carbon and the chlorine do not have much kind of polarity difference, and that's why they are known as non-polar. Now come to polar molecules. As the name suggests, the substance like much polarity difference between them. These are known as polar molecular solid. For example, we are having SO2, H positive, Cl negative. These kind of molecules. Okay. What is hydrogen bonding? This is very simple example. Hydrogen bonding, which you know in your daily life, ice. That means the bond hydrogen with oxygen, nitrogen, and fluorine. You have learned hydrogen bonding in 11th class, in 4th or 5th chapter, I think. So you have to keep in knowledge that what hydrogen bonding wants to define means the bonding of hydrogen with most electronegative next point, that is we have already made clear about crystalline solids. I was saying there was fourth one, that was ionic. What ionic solids could be? The name suggests the constituents must contain ions. High melting point rather than the molecular solids. The molecular solids have very low melting point, but these have quite high melting. Next is the metallic solid. What metallic solid means? See, metallic solid is a little bit, deep theory, and we will study this theory in the solid state, but in after some classes have been over. Okay, so the metallic solid, I will just give an idea. In metallic solid, there is a kind of sea of electrons into which metal nucleus are embedded. Okay, we would study this. So in short, the example I would say the metallic solids are like zinc, silver, these kind of solids. And the the last one is left covalent solids. In all these solids, we have seen the arrangement as well as the bonding. Like if I'm talking about molecular solid, there was weak forces. That's why the melting point is so low, except the hydrogen bonding. And about the ionic, they have bond and A positive, Cl negative. They strongly attract each other, and that's why they cannot be melted very easily. That's why they have very high melting point. Same as it is the metallic nature, they have strong metallic bond, and the last one is covalent nature. What actually covalent solids could be? Covalent solids are not explained very well, but we have so many examples of them. For example, diamond, for example, quartz, for example, graphite. They are very bad conductor of electricity. The covalent solids are very bad conductor of electricity because in this atoms are arranged, but in the covalent molecule, like they are just shared their electrons to each other. You have studied in 11th class what is covalent nature. So covalent nature means they have just made the bond by sharing the electrons to each other. Okay, but we have exception too, that is graphite, and you know very well graphite is a good conductor of electricity. So I will give some example. Diamond, silk oxide, bad conductor. The only exception is graphite, that is good conductor of electricity. Okay, so it was all about the introduction of, this was all about the solid state, in which we have studied what actually solid wants to define you, what are the differences between what are the different types of solids on the basis of arrangement of particles, that is amorphous and crystalline, and the crystalline are also further subdivided, just to make clear that yes, on the basis of chemical bonding, they can be further exemplified and they can be further subdivided. Okay, this was the basic definition or basic introduction of solids. Okay, so now let's move to our next topic, which is quite important, that is crystal lattice and unit cell. Let's start. What's crystal lattice and unit cell? Okay, let's start. What is crystal lattice and the unit cell? Okay, for understanding what actually crystal lattice wants to define us, we can explain this. We have already seen that our crystalline solid, they are made up of in a arrangement, in a well-ordered arrangement. So crystal lattice basically wants to define you. Let me take an example. Let me show you this with diagrammatically. Suppose this is a unit, this is a kind of smallest unit of a whole system, which again and again when repeated, up and down, side, left, right, would make the complete solid. I'm again repeating, suppose this is the smallest unit, which is known as unit cell. The smallest unit, which when over and over, up and down, left and right, repeated, make the complete solid without any kind of disturbance, without any kind of, we can say, arrangement. Okay, so this is three-dimension arrangement of solid having the smallest unit, which is when repeating over and over, it would give you perfect solid with perfect shape and size. Okay, so or we can understand this is like the basic unit of life is cell. Okay, same as it is, the basic unit of solid is unit cell. Okay, this is unit cell. Now, what is crystal lattice? Lattice means area. See, solids are so much bigger. Like if I'm talking about the metal, if I'm talking about this whiteboard, but we need to study them, we need to investigate them. So we have made a particular corner just to make them further investigate. So crystal lattice is basically a kind of area, a kind of corner, which the unit cell on repeating make itself. This is known as lattice or crystal lattice. So crystal lattice is defined as the area or the we can say the arrangement, the three-dimensional arrangement, which is made by repeating of a unit cell again and again over to it. And how would we define unit cell? Unit cell is basically defined as the smallest unit of a crystal lattice. It is the smallest unit which can give the perfect arrangement. Okay, now the point comes, what are the basic natures of crystal lattice? The first point crystal lattice says that each point, you can see these points, each points in crystal lattice is known as lattice point. Second, he says these lattice points are nothing but they are constituent, like it could be atom, molecule, or ion. For example, we are taking NaCl, this is Na positive, this is Cl negative. So he wants to say that if we want to see from three dimension, it would see as a point, but these points are actually the atom, molecule, or ions. Okay, these points are known as the constituent atoms, molecules, or ions. And third point, he says that the crystal lattice is purely direction dependent. That means he says that in the whole three dimension, these lines are actually these are also point. This is also point. This is also point. These lines are okay. Let me show you. Suppose this is unit cell. These are the points, and these points are actually the constituent atoms. And he says that these lines are actually the bond between these two ions or atoms or molecules. So these lines are representation of bonding between these two atoms. Okay, this was the third property of crystal lattice. Now I would, same as it is, briefly define unit cell with 2-3 properties. Unit cell wants to define that these are the molecular atoms or ions, you know very well. Secondly, if we want to show them, this is A, this is B, and this is C. That means he wants to say okay, suppose this is A, this is B, this is C. It's like 3-dimensional X, Y, Z, this kind of. So this is A direction, this is B, this is C. This is node direction, this is complete length and also known as edge length. Edge length A, B, C. Okay, and the same as it is, these are these are differentiated, these are based on, these are arranged on different angles known as alpha, beta, gamma. Okay, and these, sir, is time is over. So these angles are alpha, beta, and gamma. About the unit edge length ABC, and we have different angles alpha, beta, gamma, and only on these angles and edge length we have different type of unit cells, we have different type of crystal lattice known as Brevis lattice. Okay, these are basically 14 Brevis lattices, but we just want to study 7 different types of arrangement of lattices. Okay, now unit cell are also of 3 types that we would start in the next class. I would just want to say that on the basis of these length and this angle, these ABC and these 3 angles alpha, beta, gamma, we have 7 different type of lattices which are very important for your exam point of view too, because we will need a table and I'll show you how to remember that particular table. On this table, any kind of crystal lattice, like we are having cubic crystal lattice, you'll get a question that explain all the edge length and angles of crystal or cubic lattice. Okay, so that we would study in our next class. This was all about crystal lattice and unit cell. I have given you a brief idea and I hope you have got that. So class, this was all about me. Thank you so much. If you have any kind of doubt or query, please ask me. This topic is quite new to you, I know that, so please ask me. से बताऊंगी, see, हमारा जो solid है उसकी main characteristics जो है, the main characteristics of solid is this, कि वो उसकी जो arrangements है, they should be repeated over and over again so that we get complete 3-dimension arrangement. यानी क्रिस्टल लैटिस हम उसे बोलते हैं जब हमारी यूनिट सेल कंप्लीट रिपीट होने के बाद एक स्ट्रक्चर हमें दे दे जिसकी अरेंजमेंट एकदम परफेक्ट हो, जिसकी अरेंजमेंट 3-डायमेंशनल में एकदम वेल ऑर्डर्ड हो. इन शॉर्ट हम बोल सकते हैं कि यूनिट सेल से हमारा क्रिस्टल लैटिस बनता है, क्रिस्टल लैटिस से हमारा पूरा सॉलिड बनता है. Am I clear now बच्चे? बहुत वास्ट टॉपिक है, बट स्टिल आई वांट टू से जो मेटालिक सॉलिड्स है, बेसिकली इसके अंदर हमारे मेटालिक आयंस आर अरेंज्ड इन सच अ वे दैट इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड इट. Suppose we are having magnesium, we are having zinc, we are having silver. So if we are talking about zinc, in zinc metallic solid, हमारा जो zinc है that is present over there, and it's like a sea of electrons. और उसके बीच में हमारा न्यूक्लियस प्रेजेंट है. काफी वास्ट टॉपिक है. I'll explain in this topic too. मेटालिक सॉलिड अलग से है जो हम पढ़ेंगे. But you must know that metallic solid means silver, zinc, copper, in which electrons and nucleus are arranged very well, perfectly. That's why they are so hard. Okay.